Assalamualaikum warahmatullahi wabarakatuh, everyone. So today I recorded this lecture of week 5, titled Chapter 3, Water and its Properties, as I cannot attend I cannot perform the live lecture because of attending the conference. Okay, so in Chapter 3 we focus on water and its properties. Okay, this slide prepared by Miss Rafida and also Miss Tabasuria. So the water and its properties is held in Chapter 3. After we studied just before this on scientific methods and biology and esteem. So let's focus on Chapter 3, water and its properties. So in this Chapter 3, we'll focus on 3.1, the structure of water, and 3.2, the properties of water. Okay, so the structure of water consists of chemical bonds of water molecules and hydrophilic and hydrophobic. For 3.2 is about the properties of water, and on this week we focus on cohesive and adhesive properties, and secondly on the high specific heat capacity. So the lesson outcomes of this chapter 3 is that you should be able to identify the chemical bonds of water molecules. Second is able to determine the structure and the properties of water. So the water is a biological medium on Earth. Okay, it exists in liquid, okay, solid, and also gaseous state. Okay, in liquid ni water lah like we drink, solid is like an ice, and gaseous state as a the warm air lah yang you warm air or gases around you. Okay, that come from water. So at room temperature, it nearly colorless. Okay, with a hint of blue, tasteless, and also odorless. No odor. Okay, so water is the common substance found naturally in all three common states of matter, and it is essential for life on Earth. So every organism require water more water than any other substances in their lives. That's why in their organism body, okay, especially for human, okay, the cells consist of 70 to 95% of water. So the structure of water, okay, in the structure of water, we will learn about the chemical bonds within the molecules. Okay, so a water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. So the molecular formula for water is H2O, a single oxygen atom. Okay, they bound with the 2 hydrogen atoms. Okay, so the oxygen atom, okay, they will add their electron valence. Okay, the outermost shell, okay, have 6 electron. Okay, however, for hydrogen atom, the valence electron have 1 electron. So the oxygen electron, okay, with this 6 electron valence, okay, have high electronegativity compared to the hydrogen atom. So this will give attraction, okay, for the hydrogen atom to move, okay, and bind with the oxygen atom, forming water molecules. Okay, so this is the valence electron at the outside, 2, 4, and 1, 1. Okay, 6 lah, 1, another 1, but they bind with the hydrogen atom, another electron from the another hydrogen atom. Okay, so this form water molecules. Okay, H2O. The water molecule is a polar molecule. Why? Because oxygen is more electronegative than the hydrogen, and is able to attract, okay, the shared electron, which is the hydrogen atom. Then this will attract the hydrogen atom to share the electron more strongly compared than hydrogen. So oxygen is more attractive and more strong to attract the hydrogen atom. So therefore water then will consist of partially positive end and partially negative end. So delta sign is the sign of is a charge. Okay, so oxygen, they have partially negative because high electronegativity compared to the hydrogen atom, which is less electronegativity, so it gives positive charge. So polar covalent bond in water molecules will result in hydrogen bonding. So they have so this water molecule form a covalent bond. Okay, polarity allows water molecules to form hydrogen bonds with each other. Okay, because of the formation of the polarity, okay, hydrogen atom juga combine with another oxygen atom from the another water molecule, okay, forming a hydrogen bond. Okay, as you can see, this is a polar covalent bond, okay, between the oxygen with two hydrogen atom. They form a molecule of water. So this is a polar covalent bond. Because of the electronegativity, they attracts to form a polar covalent bond. Okay, because of this electronegativity also, the hydrogen atom attract other water molecule to form hydrogen bond. This is hydrogen bond formed between water molecules, okay, or intermolecular forces, okay, they attract between them. So covalent bond, okay, is one of the intramolecular forces, okay. So this let's focus on the covalent bond. This is a covalent bond within the water molecules. So covalent bond is one of the intramolecular forces that hold atoms or ions together within a molecule. So the molecule is the water molecule, so the intramolecular forces between them, between the atoms, to form the water molecules. And this this covalent bond, okay, are the strongest chemical bonds than the hydrogen bonds. So they are between covalent and hydrogen. Covalent bond are much stronger. Covalent bond is much stronger. Covalent bond is a bond between two atoms, okay, and the covalent bond is formed by sharing their electrons. Okay, so we have covalent bond have two types, okay, polar and non-polar. So the water molecules example of polar covalent bond. What is polar covalent bond? Polar covalent bond formed by the unequal sharing of electrons, such as in water molecule. Why is unequal? Because they have unequal electronegativity. Okay, the oxygen has higher electronegativity than the hydrogen atom. So because of the unequal sharing, okay, this form a polar covalent bond. However, for non-polar covalent bond, they have equal sharing of the electrons between the atoms. So water molecules example of polar covalent bond because of unequal sharing of electrons. These are the tables here, okay, compare between the polar covalent and non-polar covalent bond. Okay, let's see. For non-polar covalent bond, the atoms share the electrons equally, and between atoms have similar electronegativity. Okay, so these are the characteristics of non-polar. However, for polar, okay, they are higher electronegativity of one atom compared to others. Okay, one atom is more electronegative and the atoms do not share the electron equally. Okay, covalent bond between atoms that have different electronegativity cause a partial positive or negative charge for each atom or molecule. So after they bind between the atoms, this then will form a partial positive charges. So the partial positive charges, then this, okay, as we can see, the water molecule, which is the polar covalent bond, then cause them, okay, to form the hydrogen bond between the water molecules. So they are polar molecules. Okay, water is a polar molecule because of the different electronegativity they bind, okay, and they are not shared the electron equally, and then this cause positive, they cause a partial positive or negative charges. Okay, so atoms, okay, in a molecule attract electrons to varying degrees. Okay, electronegativity is an atom's attraction for the electron in a I cannot read this slide, okay, because it's covered with my face here. So the more electronegative atom, the more strongly it will pull other atoms towards itself. Okay, so this is a equal sharing of electron between two atoms, chlorine and chlorine. So it will form a non-polar covalent bond. Again, covalent bond is a sharing of electrons. So this equal sharing of electrons. So it forms non-polar covalent bond. So bonding of electrons shared equally between two atoms. So there are no charges on atoms. So this will not form any charges on both chloride ion. Okay, chloride molecule. Okay, so this is a polar covalent bond. So bonding electrons shared unequally, okay, between two atoms and partial charges on atoms. Then, so this is a unequal share, okay, between chloride ion and hydrogen atom. So this then will form partially charges between the molecules. So positive charges and negative charges. So there is polar covalent bond is unequal sharing between of electron between two atoms. So this will form a partial charges on the atoms. Okay. Ionic bond, on the other hand, is a complete transfer of one or more valence electron, and this full charges on resulting ions. So this example of the ionic bond between atoms. Okay, so let's focus on these two non-polar and polar covalent bond. Alright. Okay, so because of the partial charges between water molecules, because of the partial charges that form in polar covalent bond, this then cause formation of hydrogen bond. So hydrogen bond is one of the intermolecular forces. Just now, non-polar is a intramolecular forces, kan? Okay, covalent bond. However, hydrogen bond is the intermolecular forces that hold molecules together. Okay, so between water molecules and other water molecules, so the bonding between the molecules kita panggil intermolecular forces. So it is a weak chemical interaction. It's weaker compared to the covalent bond. Hydrogen bond is a bonding between hydrogen atom to one of the highly electronegative atoms such as fluorine, oxygen and nitrogen. Example, bonding between hydrogen atom of one motor molecule to another one motor molecule. Positive charges of hydrogen atom dengan negative charges of partial charges of of oxygen. So this form a hydrogen bond. Next, the structure in structure of water, focus on hydrophilic and hydrophobic. So hydrophilic is a loving water. Hydrophobic, okay, scared of water. So hydrophilic molecules, okay, are substances that dissolve readily in water. Okay, hydro, water, philic, of hydro, water, and philos, loving. So in Greek word lah, hydro and philos, water, and philos is means of loving. So they are composed of ions or polar molecules. So substance or molecules, okay, that are hydrophilic mostly are polar molecules or ions, okay, such as sodium chloride, sodium and chloride ion, kan? So sodium ion is a positive charges, chloride ion is negative charges. So they are polar molecules. So they are able to dissolve in water. Like potassium ion, chloride ion, they are sodium. Okay, they are charges ion or polar molecules. So they could, or ions, they can dissolve in water. Okay, so water molecules surround each ion or polar molecule on the surface of a substance and carry it into a solution. So the water molecule will bring the ions, okay, on the surface of the solid substance and carry it into a solution. So they will bring the ions and also the polar molecules, okay, because of their charges. So ionic compounds such as sodium chloride dissolve because water molecules are attracted to the positive and negative charge of each ion. Even the molecules such as the sodium chloride, which is the ionic compound just now, okay, they could dissolve in water because of the partial charges between each ion. So hydrophobic molecules is substances that insoluble in water, cannot dissolve in water, or repel in water, or water fearing. From the Greek calls phobic, phobos, meaning fearing lah. Okay, so usually molecules that are non-polar. Okay, and example of non-polar molecules are the hydrocarbons, which contains many carbon and hydrogen bonds. So lipid soluble molecules, also example of non-polar molecules such as vitamin A, D, E, and K. So they are not attracted to water, okay, and have little tendency to surround them. Water have little tendency to surround the molecules and carry them into solution. Okay, so as you can see here, this is a water molecule. They attract each other, okay, because of the intermolecular forces, because of the hydrogen bond, and however, with the presence of the hydrophobic molecules, they cannot attach to the molecules. They are not attracted to them, and they are so they have little tendency to surround the molecules and carry them into solution. Okay, so finish with the structure of water, the chemical bonds of water molecule. Again, let's recall back what we learned about chemical bonds of water molecules. We learned about two bonds, okay, about the covalent bond, and also another one is the hydrogen bond. So water molecule is a polar covalent bond because of its unequal sharing of electrons, and also because of the one atoms have higher electronegativity than other atoms, so it form a polar covalent bond, and this polar covalent bond produce a partial positive or negative charges between the atoms. Okay, then because of the partial charges that form in from polar covalent bond, this then cause formation of hydrogen bond from the hydrogen atom with other higher electronegativity atom or negative charges, which is fluorine, chlorine. Okay, um, and the which is the hydrogen bond lah. So the hydrogen bond is very important. Why? Because it will attract, okay, it will form the intermolecular forces between water molecule. So after the bond, two types of bond, okay, we learn about the hydrophilic and hydrophobic. Hydrophilic love water, hydrophobic hate water. So hydrophilic example of substances that hydrophilic is ions and polar molecules. However, hydrophobic is a hydrophobic or is a carbon hydrogen bonds or vitamin A, D, E, K. They are examples of hydrophobic molecules. They cannot dissolve in water. So finish with the structure of water. Okay, let's focus on properties of water: cohesive and adhesive. Another one is the high specific heat capacity. As you can see, the the red color is the what we will highlight here today. Okay. So properties of water, cohesive and adhesive. Okay, is a so in general, okay, overall in this study, also in this chapter, we focus on four properties of water: cohesive and adhesive behavior. Second, ability is a high specific heat capacity and high heat of vaporization. Third, water expands as it freezes. Fourth, versatility as a solvent. But today we focus on cohesive and adhesive behavior. Second, high specific heat capacity. So what is cohesive and adhesive? Cohesive is a property in which the same molecules they stick together. Cohesive, okay, because of as you can see here, the cohesion is between water molecules. They attract between each other. Okay, they are same molecules. They stick together. Okay, so cohesion between the water molecules, because the cohesion is formed because of the hydrogen bond. Okay, so this form a strong intermolecular forces between the water molecules. So form a cohesion. Okay, however, adhesion is a property which different molecules stick together. Okay, so the water molecule with the surface and at the surface, for example, or plant cell wall. Okay, so they between different molecules, we call them as adhesion. So example here, between water and the plant cell walls, so they form an adhesion. Okay. So the importance of cohesive and adhesive is that the cohesive and adhesive is both properties that are very important during capillary action. Okay, in which the process plants used to pull water up, okay, from the ground to the plant. Okay, so to the leaves lah. Okay, so there is a capillary action, and this occur within the plant xylem. Okay, and then transpiration is a process of the loss of water from plants through evaporation. So because of the properties of water, cohesive and adhesive allow of water to evaporate, okay, during transpiration. So this is a cohesion and adhesion. Water stick to other molecules via hydrogen bonds. Adhesion, water stick to none other than water molecules. So this also by hydrogen bonds lah. For example, between water and plant leaves, okay, or plant cell wall. Okay. However, cohesion between water and water. So these are very important for water. For transpirational pool. Okay, and also during water transpiration. Another one is during transpirational pool. Okay, while water molecule being pulled from the root to the leaves. Okay, that is the capillary action. Okay, the capillary action in in plant xylem. Okay, because of the cohesion and adhesion allow the water movement from root to the leaves. Okay, and also during the losses of water on plant leaf, okay, during transpiration. So that is the importance of cohesion and adhesion. So gravity, in this slide, gravity is shown by the water drops beading up at the bottom of pine needles trying to fall to the center of the earth. Okay, the gravity, as you can see here, this is an image of, or the example of cohesion here. Okay, in which we could see a water drop. Okay, so the water, they stick together forming a drop of water. However, and this and the adhesion in which, okay, the water, um, it stick to the pine needle. Okay, um, so adhesion causes the water to stick to the pine needle, preventing it from falling off the needle. So the gravity try to pull the droplet down to the earth, to the center of the earth. Okay, and this form a water drops beading. Okay, this water drops beading caused by also by the gravity try to pull it on the ground. Okay, and the process of cohesion and adhesion, okay, form this water beading that is stick to the plant pine needle, to the pine needle. The cohesion and adhesion also form a surface tension. Okay, so surface tension is an effect within the surface layer of a liquid that causes the layer to behave as an elastic sheet. Okay, so because of the cohesion and adhesion water properties, this form a surface tension on the water surface. Okay, so the water surface, the importance of the water surface tension on the water surface is that it allow insects such as water strider to walk on the water. Okay, and also allow a small metal object to float on the surface and causes water to form a, and also surface tension also causes water to form a droplet. As you can see, as this is a water pipe. Okay, you can see the drop of water, okay, down the pipe of water, down the pipe. Okay, so that is the cohesion adhesion that led in the formation of surface tension. The importance of surface tension, again, okay, working on water, forms of small insects, okay, formation of few dewdrops, okay, and also beading of water on wax scar. Okay, these are the importance of surface tension. Okay, second properties of water is that high specific heat. Okay, high specific heat is defined as the amount of heat that must be absorbed or lost by 1 gram of substance to change its temperature by 1 degree Celsius. So again, it's about how many heat of 1 gram of substance has to absorb so that its temperature can be changed by 1 degree. Okay, so it's different from one type of substances to another type of substances. Okay, and for your information, water, it has high specific heat, means that it has to absorb water heats up more slowly, means that it lead to increase in temperature. So then compared to other compounds, and it holds its temperature longer when heat is no longer applied. So that are the characteristics of heat of water. It is high specific heat. It needs to absorb high amount of heat so that its temperature could increase by 1 degree Celsius. So it is led to increase its temperature, and it also holds its temperature longer. That's why okay, the importance of this is that this then will enables organisms, allow organisms which have a high water content to maintain a relatively constant internal temperature. So that's why in our body we have water that try to maintain or stabilize the temperature in our body, because of the water is heat up more slowly. Okay, and it able to maintain its temperature because of the water properties lah. Okay, that is the importance of this high specific heat. The importance of high specific capacity of water also, other than it stabilize the body temperature, it also stabilize the ocean temperature, which creates a favorable environment for the marine life. Okay, so brainstorming question, please go to Kahoot. Okay, and